Um, yeah, so I want to talk a little bit today about robotics. We're going to talk a lot about robots. Over the past 10 years, I've built this kind of strange specialization of traveling the world and taming robots and basically convincing them to do things that they were never designed to do. And to take these tools of automation and make them personable and improvisational, and to let them have some agency of their own. And I think that this starts to really get at this future that we're kind of racing towards with artificial intelligence and physical AI, and like just like the hardware costs of these big monstrous machines getting lower and lower and lower. Um, but robots in particular are, I find, really interesting because they've been kind of seared into our collective consciousness for the past 70 years. And like you can look at this like, swatch through the decades and sort of see that, when we think about robots and what we want from especially humanoid robots, uh, you know, I travel a lot. I talk to people a lot of different countries and cultures, and they want a robot to like make them a cup of coffee and do the laundry and put the dishes away, right? And so things like the Jetsons, which is this story from the 60s based off of ideas from the 50s or 40s, is really seared and put on a pinnacle for what the future with these machines is that we actually want. And I find that so interesting because, these aspects of fiction that we've had been told over and over and over again are not nearly as interesting as the reality of what we're living in this world today. No one who made a film in the 70s based on books from the 60s, based on ideas from the 40s, could have possibly anticipated that, a vacuuming robot chasing a duck with a cat on top is really the reality of what we're living with today. And so it's a good reminder to think that our stories that we tell ourselves of our future are really from our past. And it's up to us, all the creative minds in this, virtual space together, to start making new ones to share with the world. I'm really passionate about inventing better ways to communicate with machines that can make things. For a long time, industrial robots have been the culprit of automation and replacing human labor. Basically, all the easy tasks to automate have been automated. Now what we're working on is using these tools to enhance or augment human labor. And that to me is very exciting. Industrial robots are really fantastic CNC machines. You put a different tool at the end of the arm and all of a sudden they can do a whole different thing. So in the morning you can be doing spot welding, in the evening you can be doing painting. It's just highly adaptable. Another thing that I'm working towards is finding ways to bring these machines out of factories and into live environments. So onto construction sites or onto film sets. There's chance for unpredictable objects like people to be moving into the environment. That's one of the reasons why I wanted to build the system, to give this robot eyes so that it could actually see me and we can safely collaborate in a shared space. If I'm wearing or if I'm holding these motion capture markers, it knows where I am in space, it knows how I'm moving in space. Now all of a sudden we can give the machine a nuanced understanding of our intention in that space. You can get someone who's never seen a robot before and have them begin to do creative things with just a couple minutes of interacting with the machine. And so this is part of my journey from, I should have mentioned that I'm originally trained as an architect, but I'm just a roboticist by practice at this point. This project from about 10 years ago was really my first foray into working with big giant industrial machines. I was doing this software development for this machine to make it follow me around for a part of my PhD when I was doing at Carnegie Mellon. And I wanted the machine to like 3D print something on my body. That was kind of the trajectory that I was on for my research. But when that video hit the internet, like everyone saw that like the technical thing that I wanted to do with the robot was not what was interesting. The relationship that I seemed to have with this big giant thing that was following me around the lab like an excited puppy is what really caught the mind and eye of everyone. And standing in front of this thing, you stop feeling like a person and you start feeling like this like lion tamer in front of this 1 ton of metal and motors that could completely squish you and hopefully does not. And that's kind of how I got this nickname as the Robot Whisperer. And a lot of what I do is think about like the sensibilities that I have as an architect for how people move and behave in space. And once I learned how to talk to machines, I could give them those same sensibilities so they can see and anticipate and communicate with their own bodies. Um, I like to think about the future using this amazing diagram from Stuart Candy. And he talks about the future as like you're standing holding a flashlight, and the future is this like cone of light sort of falling off into the distance, into the void. And I like to think of industry as really they're responsible for the probable future, kind of like the brightest light right down the center of that flashlight. And research to really think about this wider possible areas of what possibly could happen, and the role of the arts as really of sitting on the edge of possible and impossible and pushing the probable towards the preferable. In my work, I've worked in industry, I've worked in research, I work in the arts. I try to really blend all of those techniques to be as impactful and reach as wide an audience as possible to really show and empower people that we can push the probable towards the preferable altogether. And this kind of holds true like through the whole history of robotics. What a lot of people don't realize is when robots first came into the workforce, it would kind of share the same time and space as robots that were being explored for art. And there were even a lot of the same engineers, people working at the same companies, in the same spheres that are developing these machines for both, industrial applications and for creative applications. And I sort of see that we have been on this timeline where robots have been pushed to be efficient and optimized and repetitive. And those are kind of the economic forces that shaped the timeline that we're on now. And with my work, I try to imagine this divergent timeline where robots for the past 50, 60, 70 years, that the economic forces that necessitated that they needed to be curious and kind and alive. And that's the try to work that I try to bring into the world. And I do this through many ways. I love working with cultural institutions like museums, science centers. I work with basically anyone who wants to try to think about what this future could potentially be. This robot, Mimas, was at the Design Museum in London a couple years ago. And she originally lived in a factory in Birmingham in the UK, living a very, very boring life, doing the same thing 24 hours a day, 7 days a week, until the curator was kind enough to let me invite her for a holiday for 6 months at the Design Museum in London. And basically, I just programmed her to do whatever she wanted, to have agency of her own, to find the most interesting people and be curious about them, almost like an animal at the zoo. And there was a lot of tech that had to be developed to make that happen. But at the end of the day, like what's amazing about putting work in museums is, oftentimes the artwork doesn't tend to look back at you. And so this was like a really great project seen by hundreds of thousands of people. And at the same time, I was working on my PhD doing user studies with, 10, 20, 30 like college goers. So the idea of just like being able to bring this out into the world and out of academia, out of the lab was so exciting and something that I began to chase thereafter. Um, I am an architect, so I like to draw diagrams and plans, but here's a little bit of behind the scenes of the tech development. This is I basically like went on eBay and bought all of the V1 Microsoft Connects I could find and made an array attached to the ceiling. So Mimas has a bird's eye view of everyone around her. And so now she knows where people are, and we can begin to track where they are, how they're moving, how long they've been there, and begin to infer a relationship that she can now use to think about who she's going to go visit, who's being too boring and doesn't even deserve her attention, and who like is a little bit shy that she could go try to find. And that's just one strategy of like taking cold, hard numbers and turning them into some emotional connection with visitors. And I was really lucky to be able to bring this into the Copernicus Science Center in Warsaw. It is now part of their permanent installation, and it went live.
A robot for the very first time.
It went live about 2 months ago, 3 months ago.
Always a getting to know you period. Every robot has a unique body, and it's my job to tease out the personality that it wants to have. We have the power and capability to build the technology that we want to see in the world. And for me, that's robots that are curious and kind and alive. One of the challenges of bringing this robot to life was squeezing in all the tech into this 4-inch shelf. I'm using advanced robotic simulation tools, depth cameras, and a lot of digital duct tape to properly misuse this machine to do things it was never designed to do. All the engineering struggles start to melt away as soon as you see the public come face to face with it. I want my work to spark an imagination in the next generation and this generation for how we actually want our technology to intersect with society. The measure of the success of the project is the amount of handprints and nose prints and even tongue prints left on the glass. That's when you know that that robot's going to be looked after really well.
So you can see I care a lot about the engineering behind these systems. It's not just a point of pride, but when people are engaging with technology for the very first time, it needs to work, right? If a robot's supposed to look at you and it doesn't, like it's very alarming that like, are you not really a person? Why isn't it paying attention to me? And so I had an opportunity also to like, what's nice about working with these machines is when a company sponsors you, you just ask for a ridiculous amount of robots and they say yes, no problem. And like, oh, I should have asked for way more if you've said yes so quickly. And so this was for the World Economic Forum and they wanted me to help the policymakers, so a completely different audience, very important people in their country and their governments. We wanted to make an installation that helped people think about this future where the autonomous machines kind of outnumber us and what sort of policy and governance principles we can have when that world arriving. And so these robots, they're a bit nearsighted. Their sensors are actually in the floor down here in the baseboard, and they're looking up at you with a worm's eye view. And that it pulls you in close to them and makes you really feel surrounded by them. But there's also some Easter eggs here too, people who are very powerful, they tend to want to conduct the world. They want to conduct the robots too. And so we have some Easter eggs in here that when like you raise your hands up to actually move the machines around, they completely ignore you and go to the next person. And when you just like relax and chill out, or lean in with your hands down, then they start to pay attention to you. So what's nice about doing this is like you're part engineer and then part Jane Goodall, where you can begin to observe human behavior and then go back, open up the brain of the machines and do these like little sociological tweaking to see how it works. This project was in Tianjin, China. And again, one of the amazing things about working with machines today, they're a lot easier to use because you can do a lot of things in simulation that you couldn't 10 years ago. Um, and so I had two robots in Pittsburgh when I developed this, and I landed 3 days before the event in China for the 10 robots and was able to get everything up and running in time for this event. There's a little like inside baseball, but I think this is the right crowd to talk about the logistics of project delivery. I'll skip ahead a little bit because I want to have some time to chat. Um, this next project, so we think about like machines that are curious and kind and alive. And this one was literally inspired by some swans that I met on the lake in Zurich. And I was so fascinated by how they would come swarm you when they heard like the rustling of paper, begging for bread, and how indignant they felt when you didn't give it to them. And the shape of their bodies reminded me so much of these machines that I was working with in a university in Zurich, that I had to sort of imagine like what if our manufacturing equipment were just like these swans, that they could see and respond to our hand gestures and come close and then get shooed away if they're with just our gestures and just our body language. How much more intuitive is this than actually like sitting down, writing code at a keyboard or a debug screen? This is a simulation tool that I helped develop while I was working at NVIDIA. This is NVIDIA's Omniverse Isaac Sim, a robotic simulation tool. And you can see the blue dots there is my live skeleton in this environment. I get the robots in simulation to behave in a certain way, and then I pipe those joint positions to the actual physical robots, and it just works because this is a physically accurate simulation environment. So this was really my very first like public live performance, which was uh, both fun and terrifying at the same time. But it's really exciting. So everyone in here does advanced robotic construction, and so for them, they're really thinking about like what can we make with these machines. And this was an opportunity to think about, well, how do we actually exist with these things on a construction site? These construction sites are loud, dusty, dirty. You can't really talk to people. Like when we work with people to make a thing, we use our body language all the time. And so why not assume that from our machines? This is another Pittsburgh throwback. I just wanted to include this in here because, part of what I do with these machines is also like it seems like it's become more of a lifestyle than a career or a job. Um, One of the amazing things about being in Pittsburgh is that there's a lot of abandoned warehouses that just need a little love. So my husband and I bought this warehouse and transformed it into a warehouse house so I could live amongst my machines in this space and really begin to think about like what's the day-to-day relationships that we would have with these machines when they're roommates, when they're not tools that you like use in a factory, when they're not like things that you visit in your office, but they're actually things living amongst you, and what like creative friction can that make? And then, we have an amazingly beautiful CNC room planned out for here because, it's Pittsburgh's the heart of manufacturing. And we found out a week after we closed on the warehouse that that would need to get turned into a nursery. And so this is my daughter, Lena, here, who is like, this is a pretty cool origin story that she was like born in a warehouse in Pittsburgh amongst machines. Um, she's a winter baby. She's a pandemic baby. And so this is like during renovation, you see the ceiling's not even all the way in. I'm a Floridian through and through. I don't do cold that well. So we decided to build a bit of a playhouse for her inside the warehouse. And then, seeing her joy on this swing made me think that like, well, maybe my robot would want to go swinging too. Like it's always pinned down in one place its whole life, and wouldn't it like to feel like the rhythm of being outside its own body as well? And so this is a really simple program. It has like 3 lines of code to get the robot to do this, and it's all just natural forces swinging it around. And then like with Lena too, she didn't get to play with a lot of kids at this age. And so I thought, well, how lovely would it be for her to have a little bit of companionship, even artificial, at this stage in her life? Here's a little bit of what the simulation looks like in Isaac Sim. And I stopped. This is like, you can see that robot is really swinging. It looks like it's about to bring down the house. We kept it nice and calm next to Lena, not to freak her out completely. And then I want to end with just a couple speed projects. So I just want to share these things almost to give you a sense of how I love to work. Of a lot of how I like to think about these things is like getting the band together to go do a fun gig. And so sometimes I reached out to my friends Loop here just through Instagram. I saw that they got the biggest possible robot that ABB, the robot that I specialize in, makes. And I just asked them, can I come and play for a week? And they said, sure, come on over. And so this thing, I'm gonna turn this up. It sounds like literally like a dinosaur.
I like
Uh,
the sound. I like the sound of
The
the
joints
people.
or the people.
Yeah, yeah.
it weighs 10,000 pounds. It's literally meant to like pick up en entire cars and flip it and put them on a different assembly line. And so I decided that we should make a giant googly eye out of it because, what else would you want to do with a big machine like this? And so this is a 2 meter sphere with a 1 meter pupil. We had a big debate over whether this is going to be like a Cookie Monster style googly eye or one with like an actual like clear floating thing, and Cookie Monster won out for simplicity. But at the end, I'm always really curious about how little our brains need to be tricked into seeing things come to life. Like these are just two simple geometries, but when they move around together and especially when they respond to you, you can start to see like the animism really come to life. And animators know this, and puppeteers know this, dancers know this too, that that motion tells a story. And it's almost like this knowledge that roboticists refuse to really acknowledge and embrace. I guess because it's more like rules of thumbs than generalizability. Yeah, but this thing is a beast. And so after the eyeball, we're like, well, let's have some fun. So we attach a big ghoul guy to it, a big backboard. This is like regulation MBA backboard here. And the way that I work too is I like to sketch with these machines. So I often bring hardware devices, MIDI controllers, game controllers, iPads to really begin to sketch in space with these machines. You can see that we are all programming way too much and need to practice our skills a little bit more in basketball. We'll skip this just to get on to the next one. And then this, yeah, not my target sport. This just happened. I just got back to Paris from Monday, and I just want to share this a little like behind the scenes. I don't know if anyone here has ever worked on a fashion show. It was my first time. Izumiyaki, who that fashion house also happens to be my favorite and the only fashion house that I know of. So I jumped at the opportunity when my friend Vincent reached out to me asking if I could hop on the project 3 weeks ago. They wanted to bring these big, giant industrial robots as these scenographic actors behind the show. And a simple ask and really hard to execute. You see here, this is like 5 a.m., freezing weather in Paris, no parking permit, that they're coming and pulling these robots off of a truck that drove down from Sweden. And they're getting driven into this old monastery that they're about to convert into this hyper-futuristic, minimalist space. And even this, like logistically, was, I thought, like the most artful part of the whole project. And just a little behind the scenes here, like it's just incredible, the production company, how they made this entire world over the course of 3 days. In the front of house here, this is like on the bottom left, it's just before the show starts. The bottom right is an exhibit after the fact. And this is probably the simplest robot motion that I've ever programmed on the machine, but the most challenging environment, super high pressure, really like had to build a queuing system because the music wasn't ready until the night before. We didn't even know there was going to be a finale and a choreography that we had to do. So everything was like live programming the robots with holding these big, like 2.6 meter wide squares that can hit literally everything. So it was really challenging and really fun, and I just wanted to drop that in as a little Easter egg, and shout out to any production teams working on events because that is a tough gig, but it was super rewarding and super fun. Let's see.
Madeline, that was awesome. I love this so much. I love this so much.
Thank you.
Okay, so we have a couple questions. I always do these things a little bit sequentially. Um, so I think Les had like a very straightforward question about like cameras. Les, do you want to ask a question?
Sure. I mean, I think using a bunch of connects is a really cool idea, but there is obviously some sort of camera on the end of the robot arm, and I just wondered what kind of camera is that? What kind of detail can it see, etc.
Sure. So the I don't know if it's better to pull up the screen and share the screen, or but there's no cameras on the end of the robot.
Ah,
Those are bolt patterns. And so that's like
mm,
that's the cool thing about these machines is like our brains, you see a pattern, you automatically see eyes. But the cameras that I use, they'll either be on the floor, like they can be in the whole environment. These machines don't have bodies like us. Their sensory organs and their brains and their bodies can be totally disconnected, which makes it amazing for making very creative spatial installations. For a long time, I've used Connect, the Azure Connect, Gen 1 Connect, which is, it was end of life in 2010. Um, and then for Warsaw, I switched that to a new Orbeck depth camera. So these are cameras that can see three-dimensional space. There's a lot of amazing algorithms out there right now that you can just use like your mobile device or a webcam to get skeleton tracking. They don't really give you accurate 3D coordinates that you can feed to the robot. The robot has its own sense of where its body is in space, and you have to align the camera's sense of where it is in space and the robot's. And also, like a lot of the algorithms that you get off of these cameras, they're meant for like they're meant for male skeleton. So, I did this performance originally and I was wearing like a longish dress and it couldn't see me because it's looking for the sticks of my legs. Um, and so if you're in the Middle East and you're working on a project where there's more like tunics or in India where there's a lot like just natural for men and women to not wear pants, then that's an issue. Or also like the museum in Warsaw had a lot of families. And so people with strollers, like I wanted the babies in the strollers to be seen because how cool is that for the mom? So I have like a skeleton algorithm and then a point cloud that's doing parsing for these features as well. So people in wheelchairs or people with strollers or people wearing tunics and dresses are not really captured by these out of the box algorithms. And depending on where you're working in the world and what context you're in, those are really important people to include in the experience.
Oh, I love it. Christopher, you had a
thank you.
question?
Yeah. I'm a embodied story artist. I build theme park rides, and I did one in Guangzhou with a robotic arm that's worked with embedded spatial augmented reality and physical space.
Amazing.
And so I was trying to explain to the programmer about the visceral storytelling we had to do with the musical storytelling, visual storytelling, the verbal storytelling, etc. And that arm is very restrictive. It's not a 6DoF simulator. When you're sitting on it, I don't know whether you ever sit on it, it has very restrictive movements. And I had to turn that into, okay, how do we do clouds? How do we floating on clouds? And so we had to make a literal puppet of it so that it can take my analog motion and convert it immediately to the digital restrictions that they had. It was really fascinating in prototyping and trying to do that. You're using devices for games and so forth. That's logical. But what other insights do you have in communicating analogically with that very restrictive digital framework?
Yeah, and also oftentimes like so for example, this fashion show is the first time I've worked on a project where they just really wanted an animated pre-choreographed sequence. And we were doing some sketching in a tool called Rhino and Grasshopper and trying to bring that into an animation software like Maya, which has a plugin called Mimic that like VT Pro Design use. A lot of people use this open source tool that
Yeah. We're using
Evan
Maya
Ackerson made.
for that.
Amazing. Yeah, it's a great animation tool. And for all of us, like we had this big friction between the creative director as well as us, like how quickly we could actually turn around and do something. There was just like a big lag and disconnect, and there was also like Japanese, French, and English in the loop, so there's a literal disconnect there. But having had you know, some analog physical thing that we could record joints and have an accurate translation would have been really great. I ended up making like a custom pipeline to like pre-design a bunch of options, be able to tweak them slightly. It automatically generates and uploads a code, and then you can queue it up. And for the final show, we then baked a sequence that we liked. So we could just trigger pre-show, click. And that was like a touch designer interface. Show, click, pre-finale, click, finale, click, and that sort of thing. So the final thing was a lot simpler than the end, but the sketching and pipeline tools to get us there were like really, really required to work quickly and be able to show, not tell, what we wanted and what we were able
And
to do.
it's a real-time conversation because you're dealing with time and movement, and they have to read it and it comes back. And we had to conjunction with visual projections.
Yeah,
And of course the robotic was on a roller coaster, so that was added to the complexity.
that's awesome.
I'm just thinking that we need more of that, what you mentioned, this communication between the analog and digital.
Definitely.
Dav, you had a question. Oh, where'd you go, Dav?
Dab,
Oh,
you're
here's
on,
there. Oh,
you're
yeah,
on
there you
mute.
are.
You might be double muted.
He's talking. Can't hear you. Okay. All right, let's hop over to Jeff Osborne, and then Dav will come back to you.
Thanks, Josh. Madeline, really cool, very interesting. So you said a couple of things that I jotted down, curious, kind, and alive, and relationship I seem to have with this thing. And I'm just curious if you feel that now or in the future, machines will be sentient, or it's sort of like the AI question, like with Chat GPT, right? That we're building this apparent language interface, you know, communication. And now you're showing us things that are very embodied. And so like the movement of these bodies in space, eye contact, all these things that could appear to be happening, to me, really sort of bypass our mammalian way of experiencing other things that are alive.
Mm-hmm.
So anyway, just listening to you, it was like, it just had me wondering, like, are you imagining a future where we're interacting with sentient machines?
I think sentience is almost, I know it's in the talk title, but I think it's not really the point, right? It's not really the point whether the entity, the mechanical entity, has sentience. It's what we perceive and how that is productive or useful for us. So I think about these things as in like legibility. So for a machine that has, for a machine that's going to be out in the world, and it has some agenda, and it's going to walk by a bunch of people in public, we can't all go like open up a computer screen and look at the debug screen and see what it's going to do. It needs to broadcast its intention around it, and hopefully be able to listen to what everyone else is doing and be a good agent or entity in that same space. So I think about this like for like delivery robots that like these little coolers that go down, like a lot of them are on college campuses, you know, there's a big problem with them getting stuck in crosswalks. And now someone in a wheelchair can't get off of the curb. They're stuck in the middle of the road going around there, right? And so there's these communication issues and these frictions that designers and architects and artists are very well aware of and very comfortable designing around the ambiguity of these situations that maybe devs or software developers aren't quite. But I think like in terms of sentience, I think that we have a lot of, you know, our life is peppered with one-way relationships, from celebrity to Mickey Mouse. You know, this is something that it holds a valuable point, and even like pets to some degree. You know, it holds a valuable point in our life. It gives something to us, and we don't really expect that that reciprocation back to it. And so I try to think of them as a sort of mirrors that are able to reflect kind of the emotions we're projecting out into the world back at us. You know, a lot of our technology takes our attention, and it's an act of kindness to give it. It's an act of generosity to give attention, and that's kind of what I try to do with my robots, at least. But that's just me, you know, and what I also work with building open source tools and building tutorials and getting the knowledge out there is so that other people with different ideas and value sets can begin to think about the futures they want to see. Because there's just not enough people looking in enough different directions. Like we gotta go breadth first. We gotta go wide and far as quick as possible to really think about what we do want these machines to do, what we do want them to interact with society. That was a long answer. I
That was a
apologize.
great
no.
Long
answer.
answer to
That was a great
No,
answer.
I'll yield to someone else, but my takeaway is that, yeah, we're building a relationship that contains compassion, kindness, potentially, and it doesn't matter if there's a sentient autonomous agent creating that. It's making the reaction that we want, the relationship we want. Thank you.
Hopefully.
All right. All right, Dev, I think you have your mic working now.
Yeah, can you hear me?
Yes.
Yeah.
Oh, yay. Okay, good. So I was really struck by on all the videos that you showed, the images of especially little kids. And I know that you're using as your primary sensors like Kinects and other depth cameras and things like that to give you the gross kind of human skeleton to work with. And so you mentioned that one where, you know, if somebody starts trying to conduct, they're going to ignore that, but they're going to. And so what I was wondering is, have you started to work with more kind of facial recognition or like smile recognition? Or like at least I would imagine you could probably start to detect waving, because it seemed like a lot of people like to wave at the
Yes.
thing, which is a
Waving,
natural
bowing.
thing. Right.
Yeah.
And so then that my next kind of related question is, have you started to use AI in order to start to collect like what is a kind response? What is a curious response? What does curiosity look like as a gesture or as a face? So that's my question about that kind of stuff.
Yeah, I mean, and a lot of these like machine learning and AI tools have been commoditized so much in the past 5 years, 2 years, 1 year. It's pretty wild. A lot of what I do is these gross, like grander gestures, these hallmarks of body language. And because I build these fluid, continuous interfaces to the machines, it's tuned in a way that you see it responding to you waving. So if it's just tracking your hand and you're waving, it's going to go like this too, for example, or it's going to tweak the front of its snout too. And so what you're suggesting is a smart way to do it. What I try to find is the clever way to do it. And a lot of these things, like this is maybe my background as a designer and artist. It's like, if I could avoid a problem and if I can solve a problem, we can get in the same end goal. And so that's kind of a methodology that I use throughout. But there's also a lot of things with collecting facial recognition, especially for children, especially in museum contexts, that are just like a no-go altogether. But I would love to do things like, I would love to be able to implement that, but I'm not sure like there is an optimal curious state, that you can begin to like recognize you are curious, you're not curious. I think it's just like this emotional spectrum that your body tends to give these telltale signs towards. But I'm very curious about it. And the tools and technology and just how easy it is to deploy now is very exciting.
Oh, fantastic. I might mispronounce your name. Yossi?
Yes, I've been addressed to as Juicy, Yussi, Yassi, and all the above. But yes, I respond to that. My sensor apparatus. I don't know. I mean, yeah, you put me on the spot here. In that, I mean, just have to say that stunning work, and this, like, I feel like there would be 100,000 questions beyond the scope of this conversation. That I'd like to hassle you about, but maybe just addressing one of them. So I've been doing a fair amount of robotics work in public space, tend to be more like permanent installations. And the way you kind of interface with the brutal danger of big machines is quite stunning. So of course, on one hand, the way I see that, so you have the robot naked, so you see the robotness of it, but then, when in the public, you have the glass wall, you have a lot of these kind of pre-programmed sequences that that it cannot escape that. And as you just discussed, the sort of a seeming sentience is anyway what you really want because it's in the heads of the users. But how do you mitigate? I mean, and then finally, events, different rules than museums because
Yes.
temporary and people can watch after this stuff. But how do you deal with the danger? Like, have you ever been hit by a robot? Do you feel the danger? Because my interface is that I haven't, but I've been through, like, I've been burned by the TÜV certification processes to get things done, and it's just so painful in the brain. I've been lucky not to have it painful in the body. But how about you?
No, safety is the first, second, and third thing to do. And a lot of times it's really about these redundant systems. And so I should also clarify that none of the motions, except for the fashion show, nothing that I do is pre-programmed. I sort of make this big digital sandbox, and then the robot is allowed to just go whichever way it needs to for that. And the kinematic solver works out those joint angles. And so like that to me is also how I design for this. You know, I usually start by the robot doing very direct things, and then I add a little bit of chaos, and it does something like a little bit different. Maybe I add a little noise and chaos and noise, and then it does something crazy. I'm like, whoa, that's scary and dangerous. I'm going to dial it back a little bit. So that's kind of the workflow, so pushing it to the edge and then stepping a half turn backwards for stability reasons mostly. But safety is really, and especially like with having these companies as sponsors, they want good press. That's the ROI for them doing these in-kind donations or financial support. They want good press around this. And there's no option for having a slip up or having a mistake. And that I think that my training as an architect helps me see around those corners sometimes. So for example, the project in London, they had this machine fencing that we tried it needed to be there. And we tried our best to make that a part of the aesthetic of the exhibition design. But they proposed the machine fencing, which had like a 4-inch gap. I'm trying to think of how many centimeters, 100 millimeter gap on the bottom. And like, that's enough for a baby to crawl under. So I had to, as not the machine safety expert, have to tell them, no, this needs to go to the ground. No, it needs to be higher. People are going to take their child and they're going to put them over the edge to do something silly because we're humans and we have to design for that as designers. We have to design for that chaos inside of it. So public exhibitions where they're not attended, there's a physical barrier, and most of the time it's a physical barrier that the robot can't physically touch. It can get really, really close, but can't physically touch. That's how I like to do that. For special projects or events or something that are being attended to, there's like for the fashion show, it was slow speed. We had a software stop and we had a hardware stop. So there's 3 layers of safety, and we had a third person who was a lookout as well. And it was a very, very controlled, people behave themselves very well at these sort of things. For the performance with the 4 robots from the ceiling, off camera, there's someone holding the emergency stop there. And that's like closed course professional driver situation. And then the platform that I'm standing on, they can't physically touch me if I'm on that platform. So I can kind of reach into their zone, but it's my hand. My hand is not going to be pinned against anything, but they can't physically touch me there. If I fell off the platform, that would be a dangerous situation, which, you know, very well could have happened. But then I had someone that is also trained to just stop everything. But those, I've literally tried to be like a person who designs zoos, where you don't want the public to see the enclosure. You want them to feel as connected to, well, not, maybe we don't get into the politics of zoos, but whatever. It's the same basic concept there, to sort of like make the connection as immersive as possible while holding on to the responsibility to keep everyone safe. Then that's not just visitors, it's the people who clean the installations, it's the people who operate and maintain too, and to think about from every perspective. Like, one of the nice things about machines that seem lifelike is that with the staff at the museums build a relationship to it, and they take better care of that installation compared to the other things that they just get a little annoyed at because it's flickering or it's broken or something. There's a real care and bond that gets made between the staff as well for these machines that seem a bit more personable than other interactive art.
Oh, I love it. Margaret, you had a question.
You already answered it.
Oh, okay, cool. You sure?
Well, just to reiterate, I work on small levels of fabrication myself, so water jet, CNC, and I will talk to everything. I will like, we're gonna have a good day. I did all the things. Let's
Yes.
get started.
Yes.
So I'm inclined to create a rapport, even if it's obviously to an object that's not going to talk to me. But I feel like in displaying these opportunities to engage, do you see technology having a leeway to be like, we're going to invest and we're going to maintain, and we're not just going to pump out products that we're going to trash in for the next series, for the next generation to have to deal with. It feels like there's opportunity to reinvest in maybe things that have already been built and saying, hey, these already exist. Can we do
Yeah.
something with them?
Well, robotic arms are great for that. Like the robots in Paris that I used last week, they were 20 years old. They like, you turn them on, they had like a picture of a CD-ROM on the splash screen, like from the future, CD-ROM. And they were actually from like the equivalent of a robot junkyard, these people that take parts and make new ones out of it. But I think in technology in general, what gives me hope for that vision of the future is just how I think we're racing towards a future where it's trivial, both in time and in money, to make software tools. And then the cost of hardware is also coming down significantly. And so I see this world where, like, instead of making like handcrafted robots or handcrafted, not as this artisanal thing, but almost like in the nature of craft, like I made a handmade card for your birthday, I made a handmade piece of software for your birthday. You know, anyone can now like get some really good Python scripts or like generate a website pretty easily just from using these large language models. And hardware, I don't think, is very far off of that. We're seeing like Android robots, humanoid robots. They were, 2-3 years ago, $250,000 investment with special licenses for what you can and can't do from it. And we're seeing amazing hardware coming from China that's like $16,000. That's only going to keep coming down and down, and the reliability going up and up. And so, not that I am advocating for a future with humanoid robots everywhere, but just as a point of contrast for, heirloom electronics, I think are going to be a thing. And a lot of it has to do with the ease at which we can actually make this tech, that you don't need a huge staff. I mean, for something like related to interactive robotics, I probably work as efficiently solo as, a 6-person team inside an ad agency. And I've been doing it for a decade, and I have really sharp tools that I've developed over the years and experiences that compound my tools. But that's like, that to me is super cool. And I can also see that my technical skill, my shelf life just got expanded by decades, right? Because I can think in Python and ask an LLM to transfer that to whatever the language du jour in the future is, and be able to talk to software and hardware, a decade from now, 2 decades from now, in a way that's still meaningful. So I think the future, I mean, I'm rooting for that future, and I'm gonna actively like help make it happen as best I can. But that sounds really great.
I love it. All right. Kimberly, you had a question.
Yes, thanks. Sorry, I'm in a noisy place, but super interesting work. I'm also at Carnegie Mellon, so
I recognize
it's
the bricks behind you. I have to
Oh,
say.
okay,
I picked it
cool.
by the bricks.
Nice.
And the cold.
Yes, it's super cold. But I guess one of the things that you said that was really interesting to me was that like the robots were getting bored by certain people in like certain exhibitions. And I wonder, like, as a programmer and kind of being the, kind of like programming what boredom means for the robot, how you define human behavior in these ways for the robot, and
Yeah.
like what is the appropriate robot response like to a boring person? Like, what do you define as a boring person or
A
boring
boring person, you
behavior,
go
and
like
what
this.
is
You're
the
just like,
what do you do
okay,
with
I'm
that?
out of this conversation.
Uh,
No, definitely, like, my DNA, my fingerprints are all over this software that's running on their brains. And so I have a little bit of my, let's be generous and call it like obnoxious, like kind a joyful, obnoxious American worldview kind of baked into this thing. So they get in your face, and then they want you to like them. And I have to imagine that's a reflection of my personality. And so like, but again, like a lot of the art of this is you're just getting like a float value out of a sensor, and how do you transfer all of that into this abstraction of a robot getting bored? And so for me, it was like the person that did have my attention, did have the robot's attention, is now not moving as much. They're stationary. Maybe their back is turned, and that adds a multiplier to like the time that their attention span has. So like they literally have like an attention span that's almost like an energy bar that goes down. Or if you're moving and your boundary box is going crazy, maybe that adds to the attention span. They stick with you longer. But it's a big thing, like for a robot to give its attention. It only has one face and one body, and how does it engage a whole crowd of people over a period of time without alienating any one of them? And that is really like a design problem. There's no optimal solution for any of this. It's all strange and weird. And that's when like designers and artists, they get to make creative decisions and say like, this is what's this, and a lot of what I do is get something moving and in front of people as quickly as possible, and then iteratively tweak, because I build a lot of knobs to tweak and tune and dial in. Again, like this idea of sketching and flow state is primal to the tools that I make to do this stuff. And there's nothing better than seeing how people react. Like you have your own assumptions, but when you see a group of people react a certain way and you can go in and tweak things as they're standing in front of the machine, then you start to build an intuition for these relationships between cold, hard numbers and the people's experiences.
I love it. I love it. I love also that this is like such a similar process. We see recurring, this sort of iterative prototyping process. All right, so I think we have time for one last question. Stacia, I'll have you ask the question, and then Madeline, after that, you can kind of sign us out a little bit if you like. I'm also going to just like add a quick link into the meeting of this is tomorrow's session with Dave and Gabe if you guys want to check it out. Just there it is for you. But all right, Stacia, you got the last question.
Hey there, I'm Stasia, and
Asia, I'm so sorry.
it's okay. C makes a J sound. It's weird, but I've been working with a lot of putting sensors on people to help with interaction, and I was curious. You spoke a little about training the robots to better recognize people who might be using a mobility aid or wheelchair. Have you considered in some future projects using sensors you put on the human guest to further interaction for people who may have mobility limitations?
Yeah, definitely. I think that's great for museum context. Like you coming out of the pandemic, no museums want things that you touch. Like, so that's a big thing but for things like trade shows or events or where there's a lot of like visitor engagement, like that's awesome. So even like these motion capture markers, for example, and embedding them into props that help like sell the experience of these things. I'm really interested in costuming the robots and puppetry for the robots, especially for theme parks. Like, and that's a great way. Like you imagine Disney Imagineering has done some of the most amazing research in robotics, in wearables as well, and these like magical devices that are meant for all kinds of people, all ages, all sizes, all abilities, to begin to engage with these magical environments. And that to me, like I haven't realized I've mentioned like Disney, Mickey Mouse a couple times here, but I really feel like we're at the era of magical realism where all of this is like the hard stuff, all of the technical challenges they're tumbling down. And now we have this wide open ceiling of our imagination. The limit is our imagination. And what I'm feeling and what I'm seeing more and more is that is a very hard limit. It sounds kind of flowery, like the limit is your imagination. But our imaginations are not that great. The technical abilities are far higher than where our imaginations are taking us, mine included in that. And so that's kind of why like I want to mobilize a generation of artists and designers to contribute their creativity in all the different directions to really begin to like push out into this amazing headspace that this technology and the development of the past 5 years has given us.
I love it. Okay, so Madeline, thank you so much for being here. This is really, really fantastic. I mean, I find this incredibly, incredibly inspiring. So many of my own little questions, but I'll save that for later. Thank you everybody for joining. Madeline, do you have anything that you'd like to sign off with? You know, anything
No,
you'd like
just
this audience to do?
you know, you can find me on the internet. Reach out to me, email me, LinkedIn, Instagram, if you want to continue the conversation. I love to collaborate, and I love to daydream. Those are my two favorite things. So don't be shy. Reach out to me.
Amazing. All right. Well, thank you so much. Thank you everybody for being here. Hope to see some of you tomorrow, next week. Have a great one. Thanks again, Madeline. Greatly appreciate you. All right. Bye, everyone.
Bye, everyone.